Let's talk about integers and math. Alright, we found ourselves back in Hytale once more, and in this lecture, we're talking about integers and math. Now, first of all, I want you to calm down a little bit. It's not going to be crazy math. It's like okay-ish math, let's say. One thing that a lot of people say is for programming, you need a lot of math skills. I would say it is somewhat true, but I think the math that is can be quite important in programming. Obviously, it highly depends on what you want to do. Let's say if you want to do anything when it comes to game development, i.e., for example, Minecraft mods, Hytale mods, things like that. Likely, some things that you will run into is things like vectors, right? So you want to know how vectors work. Maybe matrices, although that's maybe a little bit too complicated, but basically vectors, vector math is one of the big things. In this case, though, no, we're not going to go that crazy. We will start at the very beginning, and that is with addition. Okay, that is where we start. Very, very straightforward. Now, what we will have here, or what we have here, is an integer a and an integer b, and we are going to write in a new integer called sum, and this is going to be equal to a plus b. Wow. Okay, that is crazy. And indeed, what this is the plus over here is our addition operator. Now, the reason I say this is not like, oh, just a plus or, just like a plus character or something like that. No, this is the addition operator, and I specifically say it like that. This is also why I continued to say the equal sign is specifically the assignment operator. And this is extremely important. Let's think about for just a second. If we were to write, we're going to do this in just a second, but let's say if we were to write a divided by b, right? If you were to write this, from math what I write on the left side, and on the right side, it's actually very important, right? Because 1 divided by 2 is something completely different than 2 divided by 1, right? So when it comes to division, the division operator is sided, right? Whatever's on the left side and on the right side, it determines what is going to happen. And the same thing is true of the assignment as well. So you can't just, like in math, where an equal sign means the left side is the same as the right side, you cannot write a plus b equals sum. That does not work, because the assignment operator assigns the value from the right side to whatever the left variable is, right? So that is why it only works sum is equal to, and then here we have an expression. In this case, it would be a plus b. Now, if we wanted to know what that is, we can write s out. Once again, tab to autocomplete it for a system out print line. Here we're going to write sum and then plus sum. As per usual, all of the code is available to you in the description below, GitHub repository, just so you can see the entire code that we're writing over here, all available to you, so you can double check that there as well. But we're going to see, in this case, sum, this should be 300. I think my math in my head is still fine. I feel like that is okay. Let's run this, and there you go. The sum is 300. Absolutely fantastic. Now, of course, we could also then take this sum variable and just assign something new to it and output that as well, right? So we can now do another one, and we can say sum, and all of a sudden, if we just output that, then what would happen is that now we're going to sort of overwrite, quote unquote, whatever is written in sum. So if we were to do this, all of a sudden we output sum 50, because of course we have now assigned another value to the variable sum. Hopefully that makes sense. Now, here comes something quite interesting. And that quite interesting thing is subtraction. Aha, this is the next one. So subtraction, there we go. Here, what we're going to do is we're going to have an int sub, which is equal to a minus b. Interesting stuff. Now, what is that going to output? Well, it's going to output subtraction over here, and then, of course, a plus, and then add the sub over here. You can also simply, copy this, right? So you can select this, press Ctrl-C to copy it, and Ctrl-V to paste it in, and then use that as well. But in this case, we're just writing it out. That's totally fine. Or, of course, the code linked below. Let's run this, and you can see subtraction is minus 100. That's absolutely correct. If we have 100 and we subtract 200 from it, it would be a negative number. That, of course, can happen, right? Negative numbers are nothing too, they shouldn't be too crazy. Those can occur. And then we get 2. What is the next one? Well, we're not going crazy just yet. We're going to multiplication next. Okay, multiplication. What is that going to entail? Well, int mult is going to be, or let's call it multi. I think multi is a little bit of a nicer word, is equal to a times b. This is a star over here, right? So this is going to be the star is the multiplication operator. And once again, we have simply multiplication over here, and that is going to be multi, bada bing, bada boom. And what is that going to output us? Well, 100 times 200 is 20,000. Is this accurate? It is indeed accurate, 20,000. Well, my mental math has not yet betrayed me, but when it comes to the division 000, who knows? And I'm not talking about the game division. I'm talking exactly about the numbered, or like the mathematical operator division. We've seen this previously, so we have an int division is equal to a divided by b. Okay, now we see that this is marked as yellow. Now the question is, why would this be marked as yellow? Well, let's think about what that is. This is 100 divided by 200. Or if we were to do some math, we could say, wait a second, this is the same as 1 divided by 2, which is 0.5. Now here it gets very interesting, because if we output this, let's just do it, right? Division is plus division. Okay, let's just say we have that. Well, let's output this and let's see. This is going to get us a 0. Oh, okay. Well, if we hover over this, this is a warning. And this warning says that the result here is always going to be 0. Why is this the case? Well, because we're using an integer, and an integer, in this case, we can only have a 1 or a 0 or a 1. We can't have 0.5. If we want this to be 0.5, well, then we would have to do this with, let's say, doubles. So we now can do double 100, an x of 100 and y of 200, and then a double of, let's call it double division in the case, right? That's fine. Division equal to x divided by y. And all of a sudden, if we were to now print this out, right, and we say, call this double division, right, because it's the division with double, let's say, and we output double division, all of a sudden, if we do this, we get 0.5. So sometimes, if you may ask, right, oh, why wouldn't I always use, let's say, an integer or something like that? Well, sometimes we might want to use a double because we want to have, 0.5 represented over here. So it can be quite important that we have this. But regardless of that, that's division. Very important here also. Very, very important. What can we never do in division? Never divide by 0. Yes, because if we have division of, let's say, b divided by 0, what is going to happen? Well, right now, it's not going to do anything. Although it will tell you, oi, division by 0. Don't do that. Okay, but it's not going to stop you from doing that. Because sometimes it could be that you have a variable that is put through the ringer, right? Who knows? Like it's a health variable or something like that, and that gets changed every time a bullet hits the player, and at some point it might turn into a 0, right? It could be the case that this happens. And then if we do this, right, and then we have a division over here, and we output division again, what's going to happen? Well, it's going to be division by 0, and that does not work. Division by 0 does not work. This is not a thing that works, and that's totally fine. So in this case, you sometimes, well, you have to basically be cognizant of if you have a division somewhere in there, right? If you divide something, always make sure that it's not 0. It's never 0. You might have to, check it in some capacity beforehand, but that's okay. So next up, we have something that you may or may not have seen before. Maybe you have, maybe you haven't, and that is the remainder. Now you might say, remainder? I've heard about this before, but I'm not sure. That is also called the modulo operator, and that can be extremely interesting. Now it is, let's say, it has certain applications, but in this case, well, we'll see, okay? We're just going to make a remainder variable over here, and we're going to call this 100, and then we use the percentage over here, and then 2. Now, what this does is, it basically takes 100, divides it by 2, and then looks if anything remains. Meaning, obviously, 100, or rather 2, fits into 150 times, so what we would get from a division is 50, and the remainder would be 0, because it neatly fits in there. So, if we say remaining from 100 divided by 2 is what? And that is exactly going to be, well, the remainder, which, if we run this, is going to be 0. There you go. Very important here, by the way, obviously, we're going to comment out the division by 0 because that would not be good. But that is the, let's say if we divide by 2, remaining is going to be nothing. If we were to, let's say, remainder, so I just, as you can see, I just select this, press Ctrl D to duplicate it. So you can see I'm duplicate the selection, and then I am going to do a 3 right here and a 3 right here. Now what is going to remain? Well, we can get to 99. 3 times 33 is 99. Okay, so we're going to get to 99, but 1 is going to remain, right? Because 1 divided by 3 is not a whole number, therefore the remainder is 1. And we can do a similar thing with 4, let's say, and now 4 once again works in because that's 25, and that works out. So 25, like it fits perfectly into the 100, so that's going to be a 0 once again. For the remainder, a couple of things that are quite interesting. If you do remainder of 2, that basically tells you whether or not the number that you have taken the remainder of is even or uneven. Because if the remainder is 0, right? So if this is if this is 0, that means even number. And if it is equals 1, that means it is an uneven number. So that can be very important and very interesting to think about. Now, when it comes to the modulo, you're likely not going to really need it in any huge capacity. However, it might be the case that you read someone else's code, and that's why you always need to know, I mean, basically almost all of the concepts, even if you say, I might not use that or I might not need that. Well, it's still important if you all of a sudden see this, the like percentage sign, you might say, well, I mean, what does that mean, right? It's like 100% of 4. No, this is the modulo remainder operator. I also highly recommend, if this is something that you're not quite familiar with, do take a look at maybe some math lectures on YouTube or something like that to take a look at what the modulo operator all does and what it can be used for. It can be quite interesting. It can be quite useful. But like I said, it has only very restrictive sort of capabilities in the sense of what we need. But yeah, finally, we also have some math methods. So those are math methods, and those are going to be quite interesting because sometimes we need to, take a number, whatever it might be. Once again, maybe it is damage, or it might be life points or experience points. Who knows, right? And maybe what we need to do is we need to round this, right? So we can round something, and this rounding might look like this. Let's say we have a 6.4. And we want to take the 6.4 and we want to just round it, okay? How does that work? Well, what we can do is we can type in math here. Once again, very important, uppercase math, okay? So uppercase M, dot, and now we get all sorts of different methods, math methods available to us. In this case, we want to type in round. Do note once again over here that this is lowercase in this case. And we can once again just press the tab key to autocomplete this and then pass inside of the parentheses 6.4. Once more, all of the code will be available to you down below, so you can also copy it over and then change it via that. So this is going to get us, obviously, an output of 6 because, well, we're rounding, and the rules are 0.5 is going to get rounded up, and anything before gets rounded down. So let's see. Rounding is going to give us 6. Awesome. What I'm going to do is I'm going to duplicate this 4 times so that I have 4 of those. So literally just inside of that line, press Control D. You can also see what I'm pressing over here down here, right? So then we're going to change this round to floor because this is going to always round down. That's always going to give us a 6. Awesome. Just going to change the formatting here just a little bit. There you go. So that it's all going to be in the same one. So this is rounding down. We can also basically always round up. So that's going to be, instead of floor, we're going to do ceil. As in, we're going to the ceiling, meaning we're rounding up. And then lastly, we can also not round, but what we can do is, let's say we want to get an exponent, like we want to put in an exponent, a power 2, right? So exponent, what we can then do is we can use another method. So let's just delete this and let's say math dot. And here we're going to use POW. This is called POW. Now, POW might be a bit of a different connotation over here. But basically, POW over here, meaning we take something to the power of. And in this case, we take 3 to the power of 2. We can even hover over this, and it's going to explain to us everything it does. Like, look at this crazy stuff, right? It's like it says the POW method over here, and then it explains to us every single thing that happens in there. There's a lot of different stuff over here. It's pretty crazy in this case. But yeah, basically 2 to the power of 3. So there's going to be 2 to the power of 3, which should be 8 if I have my mental math correct. But I think that should be it. And let's just, once again, format this a little bit nicer. There we go. Run this, and we'll see we have 6, and then rounding down 6.0, 7.0, and here 8. Now, very interesting. This one, as you can see, was an integer, while these ones right here, they're all doubles, right? Well, if we hover over this, we can even see that in this case, let me double check, we can see this is a long, basically, this is a long integer, right? So this is going to return an integer. Interesting. Now, if we look at floor, double. Oh, okay. So that means that sometimes whatever we get back is also determined or is determined by whatever we're calling, right? So we can even see this if we do math.floor on the right side over here. You can see what you're going to get back. Interesting things, right? This is very interesting. And not only that, the floor method, if we were to type in 500, okay, that works, but it's not expecting an integer over here. What is it expecting? It's expecting a double. So let's say this is a mischievous thing. Play around with this a little bit. This is why it's called software. This is why you can play around with it. What happens if I make this a float? Let's just see. Okay. It's not complaining. It is still, it's like, oh, I want a double, but it seems like, floats, doubles, it doesn't really care about that. Let's see. So this should be floor down. So this should now be 500. Let's see if that works. And absolutely works totally fine. So you can see sometimes the code is flexible enough to, even though it expects a double, it's totally fine with a float over here in this case. Interesting. You can also, once again, this is highly recommended. I always recommend this. Be open to experimentation over here. Once again, you can't break anything. Number one, you can always go down, just GitHub repository, copy over the entire main class that I have available down there, and then you're going to have a fresh start. So anything that you might have quote unquote broken, right? You might have gone outside. Oh no, what has happened here? You can always go back to a previous version, Control Z, or you can also just copy over a working version of everything, and that's also fine. Because there are more math methods. And where are they? Well, they are, if you type in math dot, and now you can scroll. And you can continue to scroll, and you can see there's a lot of stuff over here. Not all of this stuff is always interesting or something that you might want, but maybe you want the square root of something, right? It can happen. Maybe you want to have two numbers and you want to know which one is the bigger one. Now I might say, well, wait a second, I know that the B is bigger. Yeah, of course. Here you can tell, right? But what if you might want to know whether or not the attack of a different enemy is bigger or smaller? And maybe that changes depending on all sorts of different things in your game. You have to remember that, sure, right now we've defined the exact value and it never changes for this in this case. But things change all the time. That's why they're called variables, right? Because they are variable. There you go. So that's what I highly recommend. Play around with a couple of those. That is always a good idea, right? So you can basically just type math, once again, a uppercase M in this case, dot, and then play around with a couple of those methods if you want to. You don't have to, but you can. Now, one final thing. I know we've already talked about quite a few things over here, but one final thing, and that is random numbers. Now, those are quite important, and I wanted to introduce them in a very limited way because I think that this makes sense, in my opinion. Now, there's multiple ways that you can get quote-unquote random numbers. Let's call them quotes, because they're not truly random, but in our case, it's good enough, okay? We don't need to talk about pseudo-randomness and things like that. I'm well aware of that, but right now, those are random numbers. Let's just output a random number, right? Random number between 0 and 10. Let's say for the sake of argument, okay? And how do we do that? Well, we'd say math.round. Now you might say, why do we round something? Well, because now inside of this math.round, we call math.random, and then we say times 10. Now you might ask, why do we do that? I can explain. If we hover over the random method over here, it's going to explain what happens. And this random method returns a double, right, with a positive sign. So it's always going to be a positive double that it returns, which is going to be between 0.0 and 1.0. So in order to get something from, something that is from 0 to 10, well, we need to times this by 10 and then round it, right? Otherwise, we would get a crazy number. Now, we can also, just for the sake of argument, let's just duplicate this and let's just say, you know what? I don't want the rounding. Let's just see what it comes up with like this. Absolutely no worries. That's what you can do, right? You can say, you know what, Kaupenjoe, I understand you want to round this. Let's just see what it comes up with here. I'm going to tell you it's going to be looking crazy, but it's fine because if we run this, we'll see. Yeah, it comes up with a random number between 0 and 10, including a lot of things after the decimal point. That's the thing, right? So, and if we were to run this again, you can see bada bing, bada boom, and that's the whole point. Now, you saw that before the numbers were the same. This time it's different. I believe that the randomness over here is determined by the tick of the clock. I'm not 100% sure though, so don't quote me on that. But so basically, randomness for your computer in this case always needs some sort of seed, some sort of input. Think about a Minecraft world, right? That is quote unquote randomly generated. But what does it need? It needs a seed. And that's what these random numbers here need too. And sometimes they still have the same seed, right? The same number. And that's why they might have the same number here in this case. But theoretically, they should always differ. So there you go. Really cool, really awesome. Definitely quite a few things in this particular video. Probably take a break over here, you know, get yourself a tea, get yourself a snack or something like that. And maybe, you know, but depending on how many lectures you've done before, maybe take a little bit of a break right now. If it's the first lecture of the day, maybe you have the wherewithal to like push on for maybe one or two more. But yeah, that's integers and math. We've gone through addition, subtraction, multiplication, division, even the remainder, the modulo operator, as well as some math methods, and even random numbers. Do we need to know any vocabulary after this lecture? I don't think so necessarily. I think this is pretty much it for the time being. Of course, all of this, I'm telling you guys, we're going to use all of this in a very coherent way, just in not even too long of a time, okay? I'm telling you, we're still laying a few more of the foundations, and then we're going to race through so many cool things you won't even realize, okay? I'm telling you. Getting this foundation right is exactly right. So, you know, get yourself a pat on the back that you've gone through all of this. And if you have, banger on, awesome stuff. But that's going to be it for this video right here. Hope you found this useful and you learned something new. And I'll see you all in the next video. So, yeah.